Okay, so this problem says an elevator filled with passengers has a mass of 1,700 kgs. The elevator accelerates upward from rest at a rate of 1.2 meters per second for the first 5 seconds. So it starts from rest and accelerates upward. Okay, so part A. Calculate the tension in the cable supporting the elevator. Okay, so, all right. So there's the tension, there's the weight. So for part A, we choose that direction as the positive axis. That's T minus mg equal to mass times acceleration. Okay. And I'll do the numbers, but before I do that, well, let me do this. Plus acceleration is 1.2 meters per second square, and I'll do the numbers in a second. So, and what you want to do is, this is 1.2 meters per second square, and I'll multiply this by, I multiplied this by 1, so I'm trying to find this acceleration in terms of g. And you'll see in a second why I'm doing this. So the tension is 12% greater than the weight of the elevator. Okay, so if a cable were to break, that's the time it would break, when you're accelerating upward.
Sorry, does that say G plus 1.2 meters per second squared plus 9 over?
No, G over. We're trying to write it in terms of G. See, G divided by that, that's 1, and that's the conversion factor. All right, so now if you want, you can do the numbers, but the numbers, 1,700 kgs. That's the tension, and that number will mean nothing to you guys. Okay, so this is what is more meaningful. What this tells you is the tension is 12% greater than that. When it's not accelerating, when the elevator is going at constant speed, when acceleration is 0, the tension will equal the weight. Okay. And if it were accelerating downwards, the tension will be less than the weight. Okay. So the tension is greatest when you're accelerating upward. Okay. And that's when it would break, if the cable were to break. So that's the tension in the cable. You see, that's just a number and it's sort of meaningless. Okay. This thing is much more meaningful. Okay. Yep. This is 1 plus 0.122. Yeah.
Test, would you want the more meaningful answer, or?
Oh, I mean, it's multiple choice, so you'll know what is being asked. Okay, part B says the elevator continues upward at constant velocity. So when it's going at constant velocity, the tension is equal to the weight. Acceleration is 0, tension will equal weight. For 8.5 seconds, what is the tension in the cable during this time? So in part B, okay, so when you're moving at constant velocity, the tension is equal to the weight. Okay? C, the elevator decelerates at a rate of 0.6 meters per second squared. So here's a situation where the deceleration is smaller than the acceleration rate. Okay, so here's the tension here. This time it's decelerating. The velocity was in that direction. Okay, now so now actually what we'll do is we'll use this direction as the positive direction, because that's the direction in which acceleration is pointing. Mg minus tension equal to m times a. Tension is mg minus ma. Okay, so now you see when the acceleration is in this direction, the tension is okay. Notice something. If the acceleration this were equal to g, the tension would be 0. When is this acceleration equal to g? When the cable is cut and you're free falling. Okay, and of course the tension is 0. Okay, of course you don't want that. Yeah. All right. Okay, so what is the tension during this deceleration? How high has the elevator moved above its original starting point, and what is its final velocity? Okay. All right, so you guys, do you want, okay, I'll do, this is mg minus 0.6 divided by g times 9.8. And this is equal to so during the deceleration phase, the tension is 94% the weight of the elevator. Okay? Okay, in this part, they say how high has the elevator moved about its original starting point, and what is its final velocity? The elevator decelerates at a rate of 0.6 meters per second squared for 3 seconds. Okay, so the first part was you start off at rest, 1.2 meters per second squared for that. Constant velocity for 8.5 seconds. Okay, so let's write all of that. So you start off at rest, V naught equal to 0. Okay, so that's your motion. And what you want to find is the total height you gained and what is your final velocity. All right, so we'll do this in stages. So let's find the velocity at, oops. Let's find the velocity after you've accelerated for 1.5 seconds, okay? And then you move at constant velocity. So part one, first part of the motion, second part of the motion, and third part of the motion. You start off from rest, 1.2 meters per second square. So you're going at 1.8 meters per second at that point, and then you maintain this constant velocity for 8.5 seconds. And then here you're decelerating. So let's look at part three. The final velocity is initial velocity plus acceleration times time. The initial velocity is this, 8, that's the constant initial velocity, 1.8 meters per second. Acceleration is negative 0.6 meters per second square. And you do this for 3 seconds. And so the final velocity is 0. So you come to rest. Okay. And now we'll calculate the distance traveled in each leg. Okay, so for this distance, so for the first part, your initial velocity was 0. Acceleration was 1.2 meters per second square. Time was 1.5 seconds. So for this part of the journey, that was 1.35 meters, roughly the height of a person. You got a little more, less than the height of a person. So you accelerated for that long. And then let's calculate the distance traveled here. That's done at constant speed for 8.5 seconds. So d2 acceleration was 0. d2, the distance traveled, is the speed, which is 1.8 meters per second times 8.5 seconds. So the distance traveled there is 15.3 meters. So 15.3 meters. I mean, 5 meters is roughly 1 floor. So you climb 3 floors, essentially. Yeah. And then, so this was 1.5 meters. This is 15 meters. Now let's calculate the distance traveled here. Initial velocity was 1.8 meters per second, and you traveled for 3 seconds, but you were decelerating, negative 0.6 meters per second square. So while you were stopping, The distance you traveled was, this is 5.4 meters minus, that's 1.8 divided by 2 minus 0.9 meters. Okay, so the total distance traveled is the sum of these three distances. So the total distance traveled is 1.35 plus 15.3 plus 4.5. Okay, so 19.8, 20.15 meters. Okay, so roughly 4 floors. Okay, so we'll stop here.